Have you ever found yourself lost in thought about the mysteries of the cosmos or the capability of our brain to shape our physical world? Brace yourself for an electrifying expedition as we unearth the top 10 breathtaking scientific phenomena that still baffle us. On the top of our list is the enigmatic realm of quantum entanglement. This is an uncanny domain in which, contrary to our usual understanding of the universe, particles weave an intricate bond and maintain an immediate connection, no matter how far apart they may be. This daring phenomenon, colloquially known as the spooky action at a distance, is the progenitor of the Einstein-Podolsky-Rosen paradox. Allow me to elaborate. The Einstein-Podolsky-Rosen paradox, often referred to as EPR paradox, was a thought experiment aimed to reveal the supposed incompleteness of quantum mechanics. The paradox states that the description of physical reality provided by quantum mechanics is incomplete. This gave rise to a noted scientific debate on the underlying principles of quantum theory, challenging the very foundations of our understanding. As if this weren't mind-boggling enough, quantum entanglement not only contradicts the rules of classical physics, but it also led to the formulation of Bell's theorem. This revolutionary theorem asserts that any physical theory, which incorporates locality and realism, cannot wholly encompass the predictions of quantum mechanics. Specifically, it illustrates that the physical properties of particles aren't set until they are measured, and measurement on one particle can instantly affect the properties of another, regardless of the distance. Quite a complex and captivating defiance of classical physics, isn't it? Next, we plunge into the enigmatic depths of black holes, realms where the Schwarzschild radius, named after the German physicist Karl Schwarzschild, defines the boundary of no return, a point ominously dubbed as the event horizon. The intriguing Schwarzschild radius, simply put, is the precise distance from the center of a black hole where the gravitational pull becomes so intense that nothing, not even light, can escape. In this uncharted territory, the concept of time dilation, a brain-bending facet of Einstein's theory of relativity, emerges as another profound mystery. In these zones, the Herculean gravitational pull warps time itself, a phenomenon vividly embodied by the twin paradox. This theory puts forth an amazing proposition where time moves slower for an individual traveling at near light speed compared to their stationary twin. So, if one twin embarks on a journey close to light speed into space and returns, they would find their earthbound siblings significantly aged, while they have aged very little. This is not science fiction, but an actual consequence of the fascinating physics of time dilation. These staggering phenomena compel us to reevaluate our fundamental understanding of the space-time continuum, further proving that our universe is not just stranger than we imagine, but stranger than we can imagine. Our cosmic journey now takes us into the enigmatic territories of dark matter and dark energy. These invisible, elusive, and yet crucial components make up a staggering 95% of our universe, challenging our conventional perceptions of matter and energy. Dark matter is particularly intriguing, with certain groundbreaking revelations having been uncovered through the study of the bullet cluster. This unique cosmic collision stunningly separates dark matter from ordinary matter, offering researchers unprecedented insights. Specifically, it was discovered that the gravitational lensing effects seen in the bullet cluster were much stronger than what would be expected from the visible matter alone, indicating the presence of vast amounts of unseen dark matter. On the other hand, dark energy, embodied in the cosmological constant, is accountable for the accelerated expansion of the universe. This constant, a fundamental variable in Einstein's field equations of general relativity, represents a pressure exerted by empty space, driving the galaxies apart. However, the exact nature of this cosmological constant, its origin, its quantum mechanical explanation, and why it has the small value we observe, continues to baffle scientists, making it one of the most compelling enigmas in current cosmology. These scientific discoveries and observations not only provide a deeper understanding of these elusive entities of dark matter and dark energy, but also significantly shift and reshape our comprehension of the cosmos. Transitioning next to the captivating double-slit experiment, an integral cornerstone of quantum mechanics. This experiment unfolds the enthralling wave-particle duality, the concept that all particles can exhibit characteristics of both particles and waves. In fact, when light is shown through two slits onto a screen, an interference pattern is created, indicative of light behaving as waves. However, when observed at a granular level, each photon passes through one slit only, suggesting it behaves as a particle. Further, this experiment is where we come face to face with the perplexing observer effect. Not your everyday principle, the observer effect postulates that particles modify their behavior when they are observed. For instance, when the path of the photons in the double-slit experiment is measured, the interference pattern disappears, and they behave as if they've passed through one slit only. It's this peculiar behavior that shines light on profound questions regarding the nature of reality, challenging our perception of the quantum world. Next, we plunge deep into the fascinating realm of the Mandela Effect. This captivating phenomenon, where collective memories depart from validated history, sparks intense discussions around perception, reality, and the trustworthiness of our recall ability. To enrich your understanding, let's scrutinize some discrete instances of this effect. A classic example is the widely recognized collective false memory of the Berenstain Bears, a famous children's book series. An impressive proportion of individuals distinctly recall the series as Berenstain Bears, whereas the actual title is Berenstain Bears. This discrepancy in collective memory from reality epitomizes the Mandela Effect. Adding another layer to the intrigue is the controversy over the leg color of C-3PO, the beloved droid from Star Wars. Contrary to the golden image in many fans' memories, one of his legs was, in fact, silver in the original trilogy. This stands as yet another testament to the Mandela Effect, highlighting our brain's capacity for fabricating memories that feel utterly real, yet contradict the recorded facts. Our journey continues to explore further into the mysterious world of the placebo effect. An enigmatic yet intriguing phenomenon, the placebo effect serves as a tangible illustration of the power of belief. Let's consider placebo surgery trials, where patients have undergone sham surgeries and demonstrated significant improvement simply because they believed they had a real operation. This lays bare the raw power of the human mindset. If one harbors absolute confidence in a treatment's ability to cure, it can trigger legitimate physiological changes. This also underscores the influential role that the mind plays in our healing processes. As we delve deeper into this phenomena, it's fascinating to observe endorphins, nature's own painkillers secreted by our brains, which are frequently released in response to the placebo effect, thereby affirming its profound impact. On the other hand, the placebo effect has a darker counterpart known as the nocebo effect. This refers to instances when negative expectations of treatment result in detrimental outcomes. For example, a patient expecting side effects from a medication may start experiencing those side effects even if the medication is a sugar pill. This again highlights the extensive scope and depth of psychological influence over our physical well-being. Now, delve into the intriguing world of Schrödinger's cat, a thought experiment conceived by Erwin Schrödinger in 1935. This puzzling paradox pictures a cat that, according to quantum mechanics, exists simultaneously as both alive and dead. It's not just a captivating illustration of quantum superposition, a principle asserting that any two or more quantum states can be combined to produce another valid quantum state, but a cornerstone of quantum physics. This seemingly paradoxical condition has been a source of intrigue and confusion for scientists and laypersons alike, prompting a rich variety of interpretations. Standout among these interpretations are the Copenhagen interpretation and the many worlds interpretation. The Copenhagen interpretation, which holds that a quantum particle exists in all states at once until observed, proposes that only upon observation does this state collapse into a definite state. This theory radically altered our understanding of the microscopic world, suggesting the world we see is but a partial snapshot of the many possibilities. On the other hand, the many worlds interpretation proposes an entirely different scenario. It posits that all possible alternative histories and futures are real, each representing an actual world. According to this interpretation, our universe is just one among an infinite number of parallel universes, each birthed from different outcomes of quantum measurements. These complex and thought-provoking theories not only underscore the enigmatic nature of the quantum world, but also open up a kaleidoscope of possibilities that challenge our very understanding of reality. We then delve deep into the intricacies of the Fermi Paradox. Named after the renowned physicist Enrico Fermi, this enigma ponders on the peculiarity of our isolation in a universe that's flourishing with an estimated 2 trillion galaxies. The paradox is deepened by the Drake equation, formulated by astrophysicist Frank Drake. This mathematical equation is used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy and suggests that life is indeed statistically probable. Yet, if that's the case, why hasn't there been any contact yet? Adding to the intrigue of the Fermi paradox is the concept of the Great Filter theory. This theory, proposed by economist Robin Hanson, outlines an event or stage in the development of life that most civilizations never managed to surpass. It theorizes that there is a critical stage every civilization must pass through, and failure to do so leads to extinction. This could potentially explain the silence from the cosmos. The Fermi paradox, through the lens of the Drake equation and the Great Filter theory, presents us with perplexing questions about our existence and position in the universe. Next, we delve deeper into the Uncanny Valley, a concept introduced by robotics professor Masahiro Mori in 1970. Mori's hypothesis was that as a robot's human likeness increases, so does our empathy towards it, until it reaches a certain point where it becomes almost too human-like, and our empathy quickly turns into revulsion. It's an intriguing exploration into our psychological responses and how we discern what's authentically human from what's artificial. To illustrate this, consider the humanoid robot Sophia, whose hyper-realistic features can either astound or unsettle observers. This phenomenon is not just confined to the world of robotics. In the realm of CGI, filmmakers likewise tread a fine line. Movies like The Polar Express received mixed reactions due to their almost too human animated characters, providing further evidence of the Uncanny Valley effect. In essence, Mori's Uncanny Valley is a principle that reminds us of the delicate balance between empathy and eeriness when it comes to our perception of human likeness. Finally, delve into the extraordinary phenomenon known as the overview effect, a unique cognitive shift experienced by astronauts when viewing Earth from space. This term was coined after the famous blue marble shot, the first full photograph of Earth taken by the astronauts of Apollo 17 in 1972, which became a symbol of global unity and environmental responsibility. As the astronaut Edgar Mitchell once expressed, you develop an instant global consciousness, a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. This cosmic insight, as recounted by many who've journeyed off our planet, not only reshapes their understanding of our interconnected existence, but it also elevates our consciousness about environmental awareness. These astronauts report a deep sense of connection to our planet, a profound realization of the fragility and interconnectedness of life on Earth that instigates a cognitive shift in awareness. Indisputably, the overview effect, sparked by this blue marble shot, has become a catalyst, urging us to protect and preserve our beautiful blue orb. In today's journey, we've delved into 10 enigmatic phenomena that still bewilder us. We've journeyed into the mystery of dark matter, scrutinized the riddle of black holes, pondered over Schrödinger's cat's paradox, grappled with the bewilderment of quantum entanglement, and navigated through the complexity of the universe's ever-accelerating expansion. As we reflect on these phenomenal discoveries, consider diving deeper into these topics. Maybe you'll be the one to solve these riddles. Remember, your curiosity is the ignition of scientific exploration. If this journey piqued your interest, we encourage you to research and learn more about these fascinating phenomena. Don't forget to leave a like on this video and share it with friends who are as captivated by the wonders of science as you are. Discuss the phenomenon that fascinated you the most, or suggest other scientific mysteries you'd like to see us explore in future episodes. Let's keep these inquiry-based discussions alive and continue to push the boundaries of our understanding. Until we meet again, stay fascinated, stay curious, and keep delving into the mysteries of